Hey guys, so today you are going to take care of kites on page 27 in your packets. Main thing to keep in mind with this is remember it's a video. Pause it so you can write down what you need to write down because the screen is probably going to move faster than you can copy and write sentences and things that you need. So pause when you need to pause. When it comes to a kite, definition is a quadrilateral with two pairs of adjacent congruent sides. So this is the first quadrilateral that we have that doesn't talk about having any parallel sides. All of the ones we've done thus far, we always had sets of opposite parallel sides. Even with the trapezoid, we have the one set. So nothing's parallel in a kite. What we have are two pairs of adjacent congruent sides. Remember, adjacent means they're next to each other. So that means the two small segments on the left are going to be congruent, and say the two longer segments on the right are going to be congruent. Obviously, the direction in which the kite sits can turn and flip and all of those good things like normal, but you will always have a set of, say, two smaller congruent sides and two longer congruent sides, making the shape of your kite. Like our other quadrilaterals, we have specific properties. So the first property says that the diagonals are perpendicular. Okay, diagonals are perpendicular. So we had the property like this when we did the rhombus and the square. So this means in the center of our figure, we are going to have right angles where those diagonals cross through each other. Property 2, one pair of opposite angles congruent. This is going to be made by the non-congruent sides. So where your congruent angles are is not going to be where the congruent sides comes together. It's where you have one of each angle coming together. So in this case, with the picture I have, it's the angle at, say, the top and the bottom. You are essentially ignoring that diagonal that's breaking it into two pieces. We are talking about the angle as a whole. However, the pieces would be the same. So, for example, if you have, say, the small piece on the left, the little bit larger piece on the right, those pieces are the same at the top and at the bottom to get the correct total, but it's not that that angle is split into two equal pieces. So I might have 30 degrees on the left and 50 degrees on the right. That would happen top and bottom. The third property is that one diagonal bisects the non-congruent angles and the other diagonal. So this has two parts to it. It says one diagonal bisects the non-congruent angles. So if my congruent angles were those green ones that I just put top and bottom, the non-congruent ones are the ones left and right. It's saying that they're bisected. So my two pieces over here on the left are the same, and the two pieces down here on the right are the same. It's not that all four pieces are the same because the two angles were different to begin with. It's also telling you that it bisects the other diagonal. So this longer diagonal is clearly not being cut in the middle. Think about how short the piece is on the left, how long it is on the right. But the diagonal that's going up and down in this picture, where that right angle is, that is going to cut this into two equal pieces. So that means these two pieces are going to be congruent. So take a moment and look at this picture. I'm going to slide it up a little, make it a little easier to see on your screen even. We have lots and lots of markings on this kite now. And so what we want to do is just make sure we understand what is or isn't the same in these pictures. You have a kite that is being broken into 4 triangles, specifically 2 sets of congruent triangles. You have 2 small triangles on the left side. They are absolutely the same. You have the 2 bigger triangles on the right side. Those are absolutely the same. So when you get a measurement in one spot in a kite, it can always go in its paired triangle in the, say, opposite spot, right? So you always have that opportunity to put any measurement, say, in more than one location. So what we're going to do like normal is we're going to take a look at some examples using the properties of a kite and filling in various information. Okay, so if we look at the first example, we have our kite. We are asked to find W, X, Y, and Z. So what I'd like you guys to do is I'd like you to first try and find W, X, Y, and Z on your own. You might not be able to find all of them. That's okay. I want you to give it a try finding as many of those letters as you can. So hit pause on the video now and try finding W, X, Y, and Z yourself. Hopefully you gave finding the letters a shot on your own. I'm going to now go through finding W, X, Y, and Z. I'm going to go through in order just so it's easy to follow, but you can find the letters in different orders depending upon your thought process. First off, where the W is going to be congruent to the 40. That angle is being bisected, so W is simply 40 degrees. Letter X is in the middle. That's where we have our right angles, so X is simply 90 degrees. W, X, and Y are all in the same triangle, right? They're all here. So because a triangle adds to 180, and I already know what W and X are, I'm going to say Y plus 40 plus 90 makes a triangle at 180. So if this is 130, that means that Y is 50 degrees. And so lastly, that leaves us letter Z. Letter Z is over there on the right. Again, I know I have a right angle, so if I'm using that triangle, Z plus 65 plus 90 equals 180. So this is 155. And so that means that your Z is 25 degrees. So let's look at example 2. It says in kite ABCD, angle DAB is 54 and angle CDF is 52. Find angles BCD and ABC. As always, guys, I can't stress enough, label your pictures. So if it's angle DAB, if I follow those letters, DAB is going to be this whole angle here is 54 degrees. And angle CDF is 52 is just this one. Let me fix that a little bit. So there's my 52. Don't forget that you have all those right angles in the middle, right? So we also have that. It does ask me to find angle BCD. So angle BCD is that whole angle at letter C. What's important to remember is that that is one of the angles that's going to be cut into 2 equal pieces. So the fact that I know that these 2 pieces are the same means if I can find one piece, that means I know the other to put it together. Well, look where we are. We have a right angle, we have a 52 degrees, so I'm just going to call this one piece that I need letter X. And so I'm just going to say X plus 52 plus 90 makes 180. And so if I find my value for X, that means I'm looking at 38 degrees. So if X is 38, the key is both pieces there would be 38. So your measure of angle BCD, that whole thing, whether you say 38 plus 38 or you could say 38 times 2, the point is we need both pieces, and so it's going to be 76%, or not percent, degrees. So that leaves us with angle ABC. And so angle ABC, use my color here, is the whole angle up there at letter B. Now, remember that we do have congruent angles. So if I have the 52 down there at letter D, that 52 would go there at letter B. So really I just need to find the left-hand side of that line. They did give us the 54. That 54 is the angle that's going to break into two congruent pieces, right? So if this is 54, it's going to break 27 and 27. And we know we have a right angle. So I'm going to use a placeholder of Y. Let's get that left-hand side, and we'll be able to put our two pieces together. So we're looking at Y plus 27 plus 90 equals 180. So solving for Y is going to be 63 degrees. That means that the measure of angle ABC is the 63 plus the 52 that's right next to it. That's going to give me the whole angle up there at letter B. And so together, that means we are at 115 degrees. The main thing when you're looking at kites, keep in mind which angles are congruent. I oftentimes think it's easiest to think about kites as being those triangles and the fact that I have the two sets of congruent triangles, so which measurements are the same and where are they the same. So what I'd like you to do is sort of take that idea. Your homework is page 28 in the packet, okay? This is something that we should be able to get accomplished rather in a short time span, let's say. It's not a very long assignment. Mainly your answers need to go on the blanks. If you need to show work, obviously you use your space around. Needs to be on Canvas by 8 a.m. Monday for credit. Obviously, if your trapezoid homework was not uploaded for this morning, I'm not here, so go get it uploaded and get your points. I'm not checking anything until over the weekend. So take care of trapezoids if you didn't. Get your kite homework in there. Otherwise, have a great weekend, you guys.